Okay, so this is an example of one-dimensional motion and actually momentum conservation in one-dimensional motion. So you've got a ball that has mass 5 kilograms and it is moving in a northward direction and has a velocity of 2 meters per second. Okay, so it has to do with the coordinate system that is actually north, south, east, west system. So let me just draw that on the side here. So that is east and that is west. Okay. So yeah, there's a ball 5 kilograms moving north with a velocity of 2 meters per second, and there's another ball 2.0 kilograms has velocity 3.0 meters per second moving to the north too. And after the collision, ball A moves with 7 meters per second. There's a correction here, it should be 1 meter per second. So there's this ball that moves with 1 meter per second, that is ball A after the collision, and it is still moving in the northward direction. What is the velocity of ball B after the collision? Okay, so this is what's happening. There's a scene before collision and then there's a scene after collision. Okay, so there's this ball A and that is moving in the northward direction like that with some velocity VA, which is given to be equal to 2 meters per second. Okay, and mass of ball A is 5 kilograms. And there's another ball B whose mass is 2 kilograms and it is moving also in the northward direction with velocity. So this is before with velocity 3.0 meter per second. Okay, and what happens after the collision is that this ball A is now moving with velocity just 1 meter per second. So that is after is just 1.0 meter per second, and it is still to the north direction, but it is reduced from 2 meter per second to 1 meter per second. And there's another velocity of the object B, of the ball B, and whose velocity is VB after, and we don't know what that is, and that is exactly what we need to find. Now, because initially both the balls were moving in the northward directions, and after the collision they are still moving in the north direction. This is a classic example of collision but in one dimensions. So when you have collision in one dimensions, the momentum conservation equation, which should be this equals this, and this is the total momentum initial equals total momentum final. This is just a case of one dimension, so you don't really write down vectors, but you just write down the scalars. Okay, for our case this will be in north direction or north south direction, it's the same thing. Okay, so I need to just write down the sum of the momenta of the ball before the collisions. So in here, initial means before collisions and final means after collisions. So what that means is that I'm going to write down the momentum of ball A before plus momentum of ball B before, that will be equal to momentum of ball A after plus momentum of ball B after. And momentum is given by mass times velocity. In a scalar is just m times v. So let's say that all the velocities to the north direction are positive and all the velocities to the south direction will be negative. Okay, so initially we see that both the balls are moving in the north direction. That means both of these velocities are positive and positive. That means I can write down this as ma va before, and that will be positive, which we're going to use in a second, plus MB VB before, that is equal to MA VA after plus MB VB after. So MA is 5 kilograms and VA is 2 meters per second, so this will be 5 times 2. And then MB is 2 kilograms and VB is 3 meters per second, so this will be 2 times 3. And this will be equal to MA, that is 5, and VA after is just 1 meter per second, so that's 1, plus MB is 5 kilograms and VB after is what we need to find. So it will be 5 times VB after. So when you solve this, this will be 10 plus 6 equals 5 plus 5 VB after, and that is equal to 16 minus 5, 11, and divided by 5 equals to VB after, and this implies that velocity of the ball B after the collision is actually equal to 2.5 meters per second. Actually, it should be 2.2. 11 over 5 is equal to 2.2. Oh, there's a mistake here that I made. Actually, mass of the second ball MB is not 5, but it is just 2 kilograms. So that's why this is not 5 VB, but 2 VB, and therefore this will be 11 divided by 2, which is equal to 5.5 meters per second.